the wonders of variance, variance is really a sort of less obvious but very impactful aspect of data. So, for example, if a company's monthly revenue has high variance, then it is not really having a very peaceful life, because sometimes there'll be high revenue, sometimes there'll be no revenue, and so it is giving us a sense that uh, the operating strategy might have to adapt to it. You might have to have more reserve for months when you have no revenue and so on, or maybe the collection of money. Yeah, because people don't pay, customers don't pay until being chased and chased, and then they pay one lump sum. That's why your revenue variance is very high. So it in any case reveals certain problems or else the characteristics of the business that may need to be adapted to, that may need to be fixed. So variance is a very impactful aspect. Whether it's high or low, it is impactful. So we need to watch our variance very carefully. Now, suppose you take your weight on a, say, daily basis. And if you notice that after tabulating in Excel, you find that your daily weight has higher variance than maybe your siblings or your peers, or some industry average, health average that you gather from somewhere, then it may be revealing certain hidden issues or maybe even problems relating to your health, right? And likely it is not a good thing. And so because it changes too fast or too rapidly, or it changes quite wildly, right? So sometimes very heavy, sometimes very light. It may reveal some issues, and even though it is very silent, it is invisible. You just have to take into account such an observation. It's unlike average value. When you are on average heavy, you appear plump, and people will tell you, right? And hey, you seem to have put on weight, and then you may want to watch what you do and what you eat. So it's quite obvious in that sense. But variance, when it's high, when it's low, it is quite silent, right? And that's the reason why we want to be able to use the theory here to help us uh, take more conscious note of what variance reveals to us. So one example here is to take advantage of our knowledge of variance of the composite random variable, like ax plus by. We ask, we ask this question: is it possible to make the composite random variables variance? All right, think of variance as risk. Is it possible to make the risk of the composite random variables lesser than the sum of the individual risks, the variance of x plus variance of y? Okay, interesting, huh? So, is it possible? Let's try. First, we expand, right? Because of our theoretical knowledge, we can expand to a squared variance x, b squared variance y, and so on. Now, this is still a little bit tough, so we simplify a little bit. Let's suppose, for simplicity, a equals to b equals to 1. So we throw away a and b. Now we have variance of x, variance of y, 2 covariance xy. Must be less than variance of x, variance of y. So let's just call this asterisk. This inequality, we know that variance is always non-negative. The least it goes is 0. Yeah. So variance cannot cancel each other out. It will only contribute nothing. That's the best it can do. So left and right, they are of positive or else 0, non-negative values. And the only way for the left-hand side to be lesser than the right-hand side is for covariance to be negative. Don't you think? Yeah. So from this theoretical postulation, we derive this understanding that we need covariance of xy to be negative. Recall what that means. The only way for covariance xy to be negative is for the data points of xy, if you plot it on diagram, to appear mostly in the second and the fourth quadrants, right? There can be outliers here and there, but mostly in the second and the fourth quadrants to kind of form a generally a negative gradient kind of shape. So can we find such an x and y? That's now the question. I mean, if we fix x and y, then covariance is either positive, negative, or zero, whatever x and y tells us, right? So we don't have any search space. We don't have any degree of freedom to speak about. So what this means is, knowing this and assuming that we can change x and y, the question becomes, can we find x and y? Can we find x and y in such a way that calculating covariance of x and y gives us negative values? Negative small values, negative large values, it's still lesser than the original sum of the risks of x and y separately. Right now, right? So that gives us a general theoretical support to begin such a search to find x and y. Now, what is x and y that we are talking about? So obviously, if you talk about height and weight, there's no there's no alternative. But suppose we are talking about stock market, yeah, stock market. And if we are trying to say that, well, can we find two stocks that are having negative covariance? When one stock price rises, the other stock price tends to, almost always drops. Sometimes a bit, sometimes a lot, sometimes doesn't change, but most of the time it drops. So that will give rise to a negative covariance. Okay, so or the other way around, whenever stock number one drops, the other stock price always rises, or most of the time rises, sometimes a lot, sometimes by a little. Can we find such a pair of stocks? Then that will form our x and y. The prices, the stock prices will form our x and y. Yeah, so that would be a theoretical support to give us the basis to write a program and do a bit of research to scan on the horizon for stocks that give rise to negative covariance. Now, I kind of pause for a while because stock prices change. And certain times, maybe certain months, for certain quarters or certain days, or it can be seasonal, stock prices may have negative covariance or correlation with each other. And then beyond those timings, they have positive correlation with each other. So it may be a very temporary relationship between the stock prices. But if you are exploiting this relationship and your competitors are not, then you are winning. You see? So here, this is where we combine our theory and practice and say, well, knowing that this is what theory tells us, let's go and find such a pair. And of course, manual calculation will be slow. So we'll deploy software robots to go and do these calculations. See that? So if you can discover such a link, then you win because your risk is generally going to be lower than if you have than the individual sum of the risks of the variances. Now, I've given a few examples of why variance is so important, but it's also very connected to our real life decision-making processes. So think about a person who is very animated, right? To be very animated, to be very vocal, to be very, moving your hands and arms a lot when you talk and gesturing a lot. That is a person of high variance because the energy is not just high, but the energy usage is sometimes high, sometimes low. A person can be very animated when necessary and then really hold still when not required to. That's basically the high variance situation. In highly uncertain outcomes, you have high variance as well because the result can be very large, can be negative, can be zero, and financial risk is often mimicked or proxy measured by standard deviation and therefore related to variance. Likewise, creativity, very creative person, like away from average normal creativity level is of high variance too. Uh, Highly unpredictable personality is of high variance too, because it's really unpredictable, right? Whether whatever action the person will take. So all these are high variance situations, and it's very connected to our decision making in our daily lives. Sometimes we want to increase the variance, like creativity, right? We like to motivate ourselves, our companies, our branch, our colleagues to be more creative, and we want to change what we do, because if we are always sitting at the desk, always talking to the same colleague, will kind of average out each other's idea and reduce the variance, and therefore reduce our ability to think differently, right? Think out of the box and less creative. So what we do is we have to go out and meet more people, meet with more different people, right? Not just in the same industry, but different industry to get more creative. So this kind of theoretical motivation helps us to do the right thing, to get more creative, to get higher variance. Sometimes, on the other hand, we seek to reduce the variance because we realize that our business profits is having too much of a variance from quarter to quarter, thereby making it very difficult to plan, or making our stock price less attractive to investors, because it's always fluctuating, not very predictable. So how can we make our uh, company profits more attractive? It's not to increase the profit, that would be nice, but first thing first is to reduce the fluctuations, reducing the variance, right? So using theory and applying to real life to see the connection between how variance in theory behaves and variance in real life gets affected or gets measured. And that is really where we spend our time in, right? So find out the connection between the variance and real life. And better still is to uh, find out the variance of composite random variables, the one that we just explored, and how this composite random variable affects our decision making and our business.